Good day everyone, I'm Jeruzel Carpio from BSS RAE, and today I'll be talking about the Myhill Theorem for our Automata Theory and Formal Language course. In this presentation, I'll explain our language and its alphabet. I'll also define the Myhill Theorem and demonstrate how to apply the theorem to determine if our language is regular. I'll also provide clear examples of string classifications and present a conclusion about our language regularity. Let's look at our language L sub 13. This language includes all strings from the alphabet A and B that contain the substring ABA at least once. In other words, any string with the letters ABA appearing together in that order somewhere in the string belongs to this language. Here are some examples. We have ABA, ABAB, AABA, and BABA are all in our language because they contain ABA. Meanwhile, BB and AABB are not in our language because they lack the ABA pattern. So the Myhill theorem states that the language is regular if and only if it has finite number of equivalence classes. These classes group strings that behave the same way when you append additional characters. The right congruence to relation helps us group strings. Two strings are in the same group if when we add the same ending to both, they either both stay in the language or both stay out. For example, if we take AB and AAB and add A to both, we get ABA and AABA, which is both in the language, suggesting they might belong to the same group. For our language L sub 13, we can identify exactly 4 equivalence classes. We have strings that already have ABA in them, strings that end with AB and did one more A to make ABA, strings that end with A and did BA to make ABA, and lastly we have the all other strings that doesn't have A or AB at the end. Let's examine each equivalence class. For group 1, strings like ABA, BAABA, and ABAB that already contain ABA, adding any string keeps them in the language. For group 2, strings like AB, AAB, and BAB that end with AB, adding A creates ABA, putting them in the language. However, adding B doesn't form ABA, so it's not in the language. For group 3, strings like A, BA, and BBA that end with A, adding BA forms ABA, putting them in the language. However, adding BB doesn't form ABA, so it's not in the language. For group 4, strings like B, BB, or the empty string that don't have any part of ABA at the end, adding ABA puts them in the language. However, adding BBB keeps them out. So, L sub 13 is regular because it has only 4 equivalence classes, which is finite. By the Myhill theorem, this confirms our language is regular. This matches what we know. We can build a machine with 4 states to recognize this language. As a bonus, here's the DFA for this language with exactly 4 states corresponding to our 4 equivalence class. Thank you for listening. This concludes my presentation on applying the Myhill theorem to language L sub 13. Thank you so much.